Hello and welcome to our video presentation. We are excited to share our problem-based learning project for the subject SM0025 Algebra, Calculus, Statistics and Probability. In this presentation, we'll walk you through the problem, explore how we approach it and the solutions we discovered using mathematical concept. Let's get started.
In this PBL, after assessing the given URL, our group chose the Annual Early Childhood Debt category as the focus of our data analysis. We selected 3 states, which is Sabah, Sarawak, and Selangor. The data we collected are from 2001 to 2015 to satisfy the minimum sample size requirement of n equal to 15. From the data, the independent variable is the year, while the dependent variable is the total number of debt recorded annually among children under 5 years old. We extract the relevant data and organize it into the Microsoft Excel for analysis, graph creation, and calculation. The purpose of this analysis is to summarize, visualize, and compare the frequency and distribution of childhood debt in each state using various statistical techniques such as class intervals, frequencies, graph, and summary measure like the mean and standard deviation. The purpose of this is to help us understand trends and differences between the states better and discuss the possible factors influencing this pattern. For question 1b, first we need to sort the data in ascending order to make it easier to identify the minimum and maximum values. Let's take the data of Sabah as an example. After sorting it out, we can see that the minimum value is 121 and the maximum value is 766. Now, to determine how many classes we should create, we will use Sturge's rule using this formula, where n equal to the total number of data, which is 15 in our case. Just type it in the calculator and we will find that the number of class interval needed is 5 classes. Next, we need to calculate the class width using this formula. After we calculate it, we will get 129 width. Using that, we can finally build the class interval. Starts with the minimum value, 121, as the starting point. We add it with the class width, 129, and then subtract it by 1 to define each range. Why we subtract by 1, you may ask? Well, it's because the interval that starts at 121 are also included. So to make sure that there are exactly 129 value in the range and not 130, we subtract it by 1. So the first class interval will start from 121 and ends at 249. To avoid overlapping, we add 1 to the previous answer before building the next class interval. This means the second class will start at 250. Repeat the same process and we will get 378. Now we just have to continue this pattern with other classes. The interval will look like this. Here we added extra class to include the maximum value, which is 766. Once the class interval are set, we can find the frequency by counting how many values fall within each class interval. Using the sorted data of Sabah, for the first interval, the number that fell within this range are this. Since there are 9 values in this range, the frequency for this class is 9. Repeat the same process for the remaining intervals to complete the frequency column. After it is completed, we can finally find the cumulative frequency by adding each current frequency to the previous cumulative frequency. The first cumulative frequency will remain the same, since there are no frequency before it. For the next cumulative frequency, we can find it by adding the current frequency with the previous cumulative frequency, and keep doing so to the other remaining frequency. Now that we have completely structured the data for Sabah, we apply the same procedure for Sarawak and Selangor to complete the full table. Now that we have completed the data, we can use this frequency distribution table for the next question.
So for question 1c, we will use the data of each states to make histogram, frequency polygon, and OGIF. So we will just insert all the data of each states in the table. Make sure to choose string for the class intervals with the nominal measure. So we will start with selecting chart builder. For histogram, we choose bar and select the first one. Insert the class interval to x-axis and frequency to y-axis. For the statistic, choose value. Make sure the direction of x-axis bar always ascending, and the histogram can be used. To make OGIF, we will use the same method. For this, we choose line and select the first one. As usual, insert the x-axis as class interval and y-axis as cumulative frequency. For the statistic, choose cumulative sum. X-axis bar will always be ascending, and we can create the OGIF. We also use the same method for the frequency polygon. We choose line and select the first one. After that, insert x-axis as class interval and y-axis as frequency. For each statistic, choose value. The same as histogram and OGIF, the direction will always be ascending for x-axis. And vice versa, we have completed all and ready to use.
So for question 1D, we have to list out all the data for the state. So here I'm choosing the Sabah one. So to find mean, we must use this formula. And then we input all the data into the formula with n equal to 15. Type it in the calculator and we can find the mean for Sabah. And for standard deviation, we can use this formula. And then we input all the data related into the formula and type it in the calculator. And then fill it in the table. To find the quartiles, we must first open the Excel Microsoft. The data we have inserted in the Excel Microsoft are then selected and sorted in ascending order so that it's easier to find the quartiles. So now I'm gonna fast forward and do the same thing for the state Sarawak and Selangor. Now that we have organized the data in ascending order, now it's easy to find the quartiles. So first we can start off by finding the second quartile, which is the data in the middle. And then we can find the first quartile and the third quartile using the same method. Now that we have found the quartiles, we can find the interquartiles range by subtract the Q3 with Q1. Using the same method for Sarawak and Selangor, this is what we get. Following the rubric, we will change the answer to 3 significant figure.
So for the question 1F, the discussion for the question 1C, we will start with the observation of histogram. For Sabah, the class interval with highest frequency is within the range of 121 to 249. It has the largest number of data points. This shape is right-skewed distribution, means that it is positive skew. The value of mean is greater than median. Majority of data concentrate on the left side of histogram. The tail extends towards right. It means it has the lower frequency. For Sarawak, the tallest bar falls at the class interval of 330 to 356. It has the largest number of data points, means that it has high frequency. This type is normal distribution with a bell-shaped curve and unimodal. It has one peak and the mean and median are at here being equal. It is symmetrical and not skewed. Both tails are approximately equal. For Selangor, it has the similarity with non-symmetric bimodal distribution. It has two peaks, which is at 581 to 617 and 692 to 728. This non-symmetry as the frequency is not mirrored around the central point and one peak is more higher than the other one. The distribution show skewness as one tail is longer than the other, showing one group has extreme value of data. For the frequency polygon, just need to connect all the middle point of bars in histogram for each state. This is to get the clearer shape of distribution. All these OGIF represent less than OGIF. The cumulative frequency is being as y-axis in OGIF. For Sabah, these are the steep slope shape, means it has the presence of high frequency. The line become horizontal between 378 and 636 that indicates both class intervals had zero frequency. This OGIF proves its right-skewed shape. Next, for Sarawak, its OGIF show S-shaped curve. It rises slowly at first, increase rapidly in the middle, then levels off back, proving the bell-shaped distribution. We can see that the center has the steepest slope, having highest frequency. And then, for Selangor, the OGIF has varying slope, show non-uniform data across the range. The slope increases more rapidly in two distinct regions, show two modes, even though the OGIF shows smooths out peaks since in histogram. The presence of sharp changes in the slope at two separate ranges since at a bimodal distribution. This OGIF can help to calculate the percentiles for the summary statistics.
Alright, for question 1E, state a side-by-side box and whisker plot for integrals selected from the three states. So from the previous question, we already defined all the information that we need, which is the first quartile and third quartile for Sabah and Sarawak. So we just put it in, the informations, the data, and generate it, and we got the box and whisker plot for Sabah and Sarawak. So now we need to discuss the difference in terms of possible factors that relate to the movement of the data and conclude our finding. So between 2001 and 2015, we talk about the childhood death in Sabah, Sarawak and Selangor. They have a different trends, mostly due to difference in healthcare access and living condition. For Sabah, it's exhibit a right-skewed distributions, which is they had a sudden death in 2014 and 2015. This likely happened because many people live in remote areas with poor roads and limited healthcare. Poverty also plays a big role. In Sarawak, it showed a near normal distribution, which is centered around, so the number quite stable. So they show that the healthcare system is working well with strong public health programs and good access to services. For Selangor, it displayed a bimodal, just non-symmetric distributions. So they had two peaks in dust, which suggests big gaps between developed urban areas and rural or migrant communities. Fast urban growth can overwhelm health services. So in short, comparatively, Sabah highlights the challenge of healthcare access in underdeveloped regions. Sarawak exemplifies balanced service delivery, and Selangor demonstrates the strain urbanized place on health system.
For problem 2, there are 6 areas and the results for each areas are collected. From the data given, we need to use SPSS to make a box plot to see which areas needs to use protective EOA. And from that, we can conclude which area are within safe levels and which areas exceed safe noise levels and require protective measures.
For problem 2, there are 6 areas, so we need to key in the 6 area data into the SPSS so we can create the graph. Go to Analyze and Descriptive Static, go to Explore and select all the area and put it in the dependent list. After that, we need go to the option, the plot, and make it dependent value. So after that, we can click OK to create the box plot graph. So the graph is at the bottom, which is here shown. So that's all for problem 2, making graph.
Alright, so for the conclusion, from the box plot, we can see that in area 1, the noise levels are generally below the safe hearing level, which is 120 decibel. So no values exceed this threshold and protective EOA is not necessary. In area 2, we can see that all values are below 120 decibel, so it is obviously protective gear is not needed. For area 3, the noise level values are fairly high but still remain below 120 decibel. Hence, no immediate need for protective EOA.
In area 4, this is the quietest area with the lowest median and range of value. Hence, this is clearly the safest area. In area 5, about 25% of the reading are below the safe hearing threshold of 120 decibel. In area 6, one value exceeds the 120 decibel threshold, so it is good idea to provide protective EOA. In conclusion, area 1 to 4 are within safe level, with area 4 being the quietest. Area 5 and 6 exceed safe noise level and require protective measure.
That's all from us. Thank you.